friend's earnings at time 0. Okay? Let y0 indicate my friend's earnings at time 0. And suppose he came with a completely empty wallet. So he had no money. What will be his earnings in y1? If you look at the amount of money in his pocket, what is the amount of money in his pocket in y1? He had 0 rupees to start with, and the frog jump to the right, he gets +1. Frog jumps to the left, he gets -1. So in fact, the frog's jump is a statistical experiment. Where the frog will jump is an outcome of a chance experiment. So my friend's earnings become a random variable. Those random variables have a binomial distribution. They can be +1, -1 with equal probability 0.5 constant. Right? So I represent y1 at 0 plus e1, where e1 is a random variable which we have taken maybe +1 or -1. So the first try the frog jumped to the left, my friend got 1 rupee, so his earnings became 1 rupee. If the frog jumped the other way, he lost 1 rupee, so his earnings became -1. Now at y2, what will his earnings be? Not his earnings. How much is the money? If I want to count the money that he has in his pocket, the money that keeps on accumulating. Yeah, so it would be whatever money he had at y1 plus whichever way the frog jumped. Right? What will be his earnings at y3? E3. So in general at time t, his earnings will be t minus 1 plus t. So I have a time series because his earnings at a particular time, not his earnings, I'm using the wrong word, whatever is in his pocket, the accumulated money at time t is a time series variable because every time it changes in time. Right? And we say that we have an equation describing that yt is equal to yt minus 1 plus pt. So I will call this the frog equation. Right? I will call this the frog equation. The frog time series. Okay? The frog time series also has a very, very important statistical name. It's called a random walk. Okay, so the frog time series that I have got here is what is called a simple random walk. Okay, what I have called a simple random walk. Right? And this is very, very important time series in financial statistics. Stock prices, for example, follow simple random walks. Right? Okay, so you have a simple random walk, the frog time series. And there's a third time series, okay, which is very similar to the frog time series, but I write it as yt with the requirement that absolute value of phi is less than 1. Yeah? I say absolute value of phi is less than 1. So you see, if I let phi be equal to 1, I'll get the frog time. Right? If I let phi be less than 1, then I will get a third time series. Now let me understand some basic properties of this time series. So what is, and suppose I actually start with something. I start with, suppose I had some alpha amount of money to start, right? Yeah? Then this is called a random walk with a drift. This is called a random walk with a drift. Okay, it's called a random walk with a drift. Okay? And then has a third one. Alpha plus 1/5, and let me then make it more general, just to keep the same story. I'll let it as alpha. Yeah? So I have alphas on both sides. So I have a I have a 3 time series. is called a time series with a linear trend. The first is time series with a linear trend. The second is a random walk with a drift. And the third is a particular link. Okay, this is called a AR1 process. Autoregressive process of order 1 and AR1 process. Right, so I have a linear trend time series. So first is a linear trend time series. Now let me give it the proper names. Okay, so I have linear trend time series. Yeah, and this is called autoregressive process of order 1. Why is it autoregressive? Because yt depends upon yt minus 1. Just like et depended upon et minus 1, but we did not have an alpha there. Et is dependent upon phi et minus 1. This is also an autoregressive process. So et is also a general autoregressive process between phi subsets. Right? This is autoregressive process order 1. Now let us first, so what do you think will be that, so what will be expectation ht? What is the expectation ht? Alpha plus beta t. Because alpha is a constant, beta is a constant, t is a constant. Alpha plus beta t. So the important thing is the mean of this time series is a function of time. Yeah? What do I mean by that? So if this is this time series, if I take the average of the data between these points and the average of the data between these 2 points, I'd obviously get a different number. So the mean of this time series depends upon time. Yeah? The mean of this time series depends upon time. Okay. What do you think about this time series? Will this mean also depend upon time? There is no question of probability in statistics. It is or it is not. Will it or will it not be? Look at it this way. So I can write yt as alpha plus yeah. Can you tell me why? Because yt is alpha plus yt minus 1 plus et. Yt minus everything goes back by 1 p, which is equal to 2 alpha yeah. But I can do the same thing to t minus 2 yeah. Right? Sure? So this will be et minus 2 plus et minus 1 plus et, right? I can keep on going back like this. Suppose I go back j periods. Right? I go back j periods and suppose that j period back value of y was 0 for simplicity. Or let's not even think of that. So if I do this j periods back, this will be equal to 3j plus yt minus j. Is it 3 to be j? Right. Right. it will be alpha j, right? Alpha j plus 3yt minus j plus t1 plus t2 plus t3, right? So basically it will be, I've gone j periods back, so it will be et plus et minus 1 plus et minus 2 plus et minus j, right? So this is my yt. Yeah? The expected value of all each of the e's is 0. Okay? So suppose you had 100 periods of data. So j is 100. So what would I say? Alpha is 5. So this will be 5 into 100 plus the value of y 100 periods back plus E1 plus E2, E100, the error in the 100 periods ago, plus error in the 97 periods ago, plus error in the 98 periods ago, plus error 97, etc. Now, if you take expectation yt, alpha j is a constant, yt minus j is a constant, and yeah. Now all these expected values are 0 because the error term has a mean 0 at each point of time. Right. So what do I have? So in the second equation I have, from this it follows that expectation yt is alpha j plus yt minus j. Right? Expectation yt is alpha j plus yt minus j. So, is this clear? Can I wipe this off? So, what I have here is yeah. So, suppose P is 100. We are in the 100th period. So what is j? We have gone back 99 periods to the beginning of time. So j will be 90. So the value will be alpha into 99 plus yt minus 90. So the first value. The next year, what will be the expected value? Alpha into 100 plus the first value. The period after that it will be alpha into 101 plus the first value. The expected value of y will keep on changing. Right? Expected value of y will also be a function of time. Right? So, in this case, as well as in this case, expected value of yt's are changing with time. The expected y is changing with time. Right? Yeah. So, suppose I am in period 100 now. Right? So, what is the expected value of y today? Alpha, which is 5, into how many periods back I can go from the beginning. So each alpha has to be multiplied by as many time periods that I have. That is j, right? How many time periods do I have? 100 time periods. So alpha into 100 plus yt minus 100, that is the beginning of y. Now next, so that would be 500 plus the first value of y. The next year, I'll have 101 time periods. So it will be 5 into 101 plus the first value of y. The year after that it will be 5 into 102 plus the first value of y. So 5 into 100, 5 into 101, 5 into 102 will keep on changing over time. So therefore the expected value of yt is also a function of time. If alpha is 0, it will all be 0. But otherwise it's a function of time, right? Okay, it's a function of time. Sure? Okay, so in both the cases, expectation yt and expectation ht, both in the random walk with a drift and a linear time series, also both of the means of y depend upon time. Right? The means of y depend upon time. Sure? In this case, however, if you have yt is alpha plus phi yt minus 1 plus et. Can you now backward substitute and tell me what this equation will be? What I did was called backward substitution. Right? So this becomes yeah. Right? You see how it's easy, no? So now instead of yt minus 2, now what should be the next step to do? What will be the next step? I can do the same thing for yt minus 2. So what will I get? Yeah? Plus of course. Yeah? What will this be? Alpha phi cube plus what will I have? What will I have? Phi cube is phi square et minus 2. Yeah? So if I do these j periods ahead for the previous j periods, what will I get? Can you derive from it a general formula? If I do this 7 periods back, what will I get? So keep on doing this for yt minus 3, substitute for yt minus 3, substitute for yt minus 4, substitute for yt minus 5. So just do t minus 4, t minus 5 and you will get some picture of where it is going. Do that. Do that. You never learn any statistics without doing that. Hatu, leave. Yoku no go. हंस तो गए. So what will it look like? Can I wipe this off? No? So this is going to look like up to say alpha phi raised to j if I do this j times plus y raised to j, sure, because that 3 is going to be j, plus et plus phi et minus 1 plus phi square et minus 2 plus phi cube et minus 3 up to phi raised to j minus 1. Yeah? This is what I'll get. Sure? Now in theory I can keep on doing this ad infinitum. if I were not really prepared for class, I'll ask you to do this again and again and again and again. So I have nice and some bracket as not finished, right? Okay. So if I change this, now pay attention. I can actually write this as this can be written as so on for several terms ad infinity, right? Plus, what will be 5 is to j, yt minus j becomes very large. 5 is less than 1. Suppose 5 is 0.7. So we are looking at 0.7 square, 0.7 cube, 0.7 raised to 7, 0.7 raised to 30, 0.7 raised to 500. It will keep on becoming small. So as j tends to infinity, this curve will drop off. Yes? So I have this first term in alpha, several of them with that, plus I have et plus phi et plus phi square et minus 2 like that. Yeah? And we'll go on and on and on. Now this first part can be written as so on and so forth, plus dot 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 dot, right? Plus summation phi raised to j et minus j goes from 0 to infinity, right? Now notice that this first part, what is inside the bracket? 1 plus phi square plus phi cube, etc. All the values of phi are less than 1, right? So you have 1 plus NPC plus NPC square plus NPC cube. That's a geometric progression. And what is the limit of a geometric series? It then becomes large. 1 upon 1 minus NPC. No? 1 plus NPC plus NPC square plus NPC cube. So what is this bracket inside? It will be 1 upon 1 minus phi. The bracket inside will be 1 upon 1 minus phi. Yeah? 1 upon 1 minus phi. Because 1 plus phi square etc. that goes to 1 upon 1 minus phi. So this will be equal to yeah? Okay? Right, folks?
Why did we eliminate phi raised to j by the
Because j becomes very large, phi raised to j will become very, very small. It tend to 0. Right? Sure? So the important idea is, for the autoregressive process of order 1, yt can be written as yeah? Sure? Alright? So what is the capacity? What is the expected value of yt? What is the expected value of yt? Perfect. So what is this? This is the long-term average of y. And does this average depend upon time? No, it's a constant. So if alpha were 5 and phi were 0.5, if alpha were 5 and phi were 0.5, this will be 5 upon 1 minus 0.5, 5 upon 0.5, which will be 10. It will remain fixed. So one important difference between the three models here is that, okay, one of the important difference between three models is that here also midpoint, but here right, so those three processes are quite different from each other. The first two processes seem to belong to one class, where their means vary with time. The last process, the mean does not vary with time. Right? Actually, the first two processes are not one of the class. They are different in their own, each in their own particular way, and we'll now see how that goes. Correct? So expectation YT आ गया सबको? Right? Sure? Okay. So here, if this is expectation YT, okay, this farak is clear? This, the mean value depends upon time. The mean value depends upon time. The mean value does not depend upon time. Right? So at AR1 process, the mean value does not depend upon phi is less than 1. If you make phi equal to 1 or greater to 1, it will go 1 upon 1 minus phi will not converge. Right? So therefore phi is less than 1 is critically important. Phi is less than 1 is critically important. Right? The first two processes, the mean depend upon time. In the last process, the mean does not depend upon time. Okay. Sure. So now, so what is now variance of HT? How do you define the variance? Yeah? Is equal to what? This is HT, this is expectation HT. So what is the gap? Which is the variance of it. Alright? This is HT, this is expectation HT. So HT minus expectation HT is ET. ET square. This is the variance of ET. And we have assumed that the variance of ET is constant, it is sigma square ET. Alright? So even though the mean of the first process changes in time,